Hey everyone, so we're going to talk about forces, push and pull forces, the laws of motion, Newton's laws, and stuff like that. So the first picture here is someone on a bike, and that is an example of force because when you're on a bike, you are using your feet and you're using the pedals to kind of move and propel yourself forward, which is a force. And then So, kinematics is the study of motion that does not consider what causes the motion, and dynamics is a branch of physics concerned with the study of forces and how they affect motion. So, force is simply defined as a push or pull, and this is what causes the motion. The unit for force is newtons or N, and there are many different types of forces, and they all have different magnitudes and directions. So both of these images right here show kinematics and forces because they both show the trajectory of a ball going upwards, and it focuses on the position, velocity, and acceleration of the ball, and it doesn't really pay attention to the force of gravity that's acting on the ball. So that shows kinematics. The first force that we're going to talk about is applied force. So, an applied force is a force that is applied to an object by a person or another object. An example of an applied force would be this man pushing on this box because the two objects are physically interacting with each other. So, the man is pushing on the box, and the box is pushing, I guess, kind of on the man, and the man is applying a force to the box. And then the next force we're going to talk about is the force of tension or tension force. So these people here are pulling on a rope. They're playing tug of war, and the people on the other side are also pulling on the other side of the rope. And this kind of shows tension force because tension force is the force that is transmitted through a string or wire when it is pulled tight by forces acting from opposite ends. So these people represent tension force because they are pulling on that rope and the opposite forces are acting from both ends. The next force is the force of gravity, which is the force with which the Earth, Moon, or other massively large objects attract another object towards itself. So these two images both show the force of gravity because in this one here, gravity is pulling down on the apple. So the apple was in the tree, and then it pulls down on the apple, and the apple falls out of the tree. And then if you were to throw like a ball or something, anything in the air, gravity would pull that thing downwards, and that would be the force of gravity acting on that. And then for normal force, the normal force is the support force that is exerted upon an object that is in contact with another stable object. So this photo shows the normal force that the table is exerting on the book, and that would be an example of normal force. And then the force of friction is the force exerted by a surface as an object moves across it or makes an effort to move across it. So in this picture here, the box is creating friction because the boy is pushing on the box, and that's creating friction because the box is moving across the surface, and the force of friction is acting opposed to that forwards movement. And then air resistance is a special type of frictional force that acts upon objects as they travel through the air. So this man parachuting, or he is an example of air resistance because when he's jumping from the plane or whatever, he the air resistance is pushing up against him, and then gravity is pulling him down. So those two are acting in opposite directions, and this shows kind of air resistance pushing up against the man. The spring force is the force exerted by a compressed or stretched spring upon any object that's attached to it. So this picture is an example of a spring force because the spring is kind of compressed and it's acting on the object below it, the ball, and it's pushing a force against that ball. So the last things to note, important things, are Newton's laws. So the first law is that an object at rest will stay at rest and an object at motion will stay in motion. This is also known as the law of inertia. And then the second law is that force is what makes an object change its acceleration. This is also known as force is equal to mass times acceleration. And then the third law is that every action has an equal and opposite reaction. So these three laws of motion are essential when studying forces because they establish the relationship between forces and the resulting motion of objects. And then net force is when multiple forces are acting on a system. You're going to add all of those forces together, and that's going to give you your net force. And then the last thing is that if you have two forces that are going in opposite directions, one's going to be positive and one's going to be negative. And depending on how big one or the other one is, sometimes they're going to cancel each other out. And then a free body diagram, or an FBD, is what we're going to use to represent these forces. So a free body diagram is going to be a physical representation of all the forces that are acting on an object or system. They're represented as vectors or arrows, and they're always drawn to scale. So you're going to start off with like a point or a box that's going to represent your object or your system. And then from there, you're just going to draw arrows coming from it that are going to represent the different forces that are acting on that system. And then the last thing that we're going to talk about is equilibrium. So when you're referencing net force, it's important to note that when you have two forces that are acting on an object and both of them are the same amount and going in opposite directions, they're going to cancel each other out and produce what's called equilibrium, which is when your net force and your net torque on your object are zero, and it's going to result in no change, which means that an object can be at rest and have a constant velocity, but it's not accelerating. And this is the end, so thank you for watching, and I hope you enjoyed and you learned something.